Now, UGB question number 2 here. Suppose is n greater than 2. Consider the polynomial. Show that the equation has only two real roots, namely 0 and 1. Okay. Qn of x here. 1 minus x to the power n. He root pahnih chaw a nei an tia q1 le so this is equal to 1 minus 1 minus 0, so this is equal to 0. Dik ngay ya check ve mai meang root min pek sa hi 1 minus 0 minus 1 minus 0 to the power n, so 1 minus 1 0 ni le ta, so kan mua 0 le 1 a root a om an tia a om ngay boka hemi te pahnih chaw hi root a om ti proof angai ta ni. Qn prime of x derivative zong taila minus nx to the n minus 1 minus n but plus ani don ta to the n minus 1. So 1 minus x differentiate let's 1 minus and so critical point zongela, so let this be equal to 0. So n a divide thea n hi 0 ni lo draw n greater than or equal to 2. Okay, n greater than or equal to 2, so you can divide. So you have 1 minus x to the power n minus 1 minus x to the power n minus 1 is equal to 0. This implies that 1 minus x to the power n minus 1 is equal to x to the power n minus 1. If you have same power, that means that either n minus 1 is equal to 0 or 1 minus x is equal to x. N is equal to 1 and box 0 because n is greater than or equal to 2. So 1 minus x is equal to x. This implies that x is equal to 1 by 2. X is equal to 1 by 2. This function has only one turning point, critical point. Mun khata chaw a turn. Shit him. By Rolle's theorem. Rolle's theorem says that f of a is equal to f of b if f of x is continuous on a comma b and differentiable on open interval a comma b, then f prime of x equals to 0 for a comma b for x belonging to a comma b titani. Now Rolle's theorem kan mang chuan hemi equation hi q of x ra qn of x hi 1 minus x to the power n minus 1 minus x to the power n. 1 minus, okay. Now we know that qn of 1 is 0 and qn of 0 is 0. So f of 0 is equal to f of 1. So by Rolle's theorem, f prime of x will have a 0 and x will belong to 0, 1. So dik ngay ta chan so x kan hmu to ha 1 by 2 tro 1 by 2. Now let alpha be a root greater than 1. Tahan 0 ama tahan 1 ama tahan 1 by 2. Now alpha hi 1 ay alien infinity eng po helai inkara hian root lo ni ro se, right? Alpha tani alpha si chuan alpha root ani chuan then qn of alpha hi 0 ani ve ngai tani chan chu root ani. So chuan f of 1 po hi root ani van 0. So f of Rolle's theorem angkan f of a equals to f of b tro f of alpha is equal to f of 1, which is 0. So chu anin kara hian Rolle's theorem kan man chuan f prime of x will have is equal to 0 and x will belong to 1 comma alpha. Ma se f prime of x equals to 0 hi x equals to 1 by 2 chawani wangin chu 1 le hemi inkar hin 1 by 2 omlo wangin contradiction. So no root bigger than 1. So tiang bogin let beta be a root lesser than 0. So then 0 1 by 2 1 oma then beta omang minus infinity le 0 inkara beta root lom le ta se. So root ani chuan qn of beta is 0 ni ngaya chuan qn of 0 po is 0 ni don ta root. Chuan Rolle's theorem apply chuan f prime of x hi 0 aniang for x belonging to beta comma 0. Masa f prime of x hi x equals to 1 by 2 chau 0 ania. Masa 1 by 2 hi 0 le beta inkara om velo wangin contradiction. So no root. Chuan nga dinge kan man ring ngot ti chuan hi polynomial ania. Polynomial hi chu an real number a top hian uncontinuous a undifferentiable bawk.